Many skyscrapers still use natural gas to heat and cool their buildings, leading to these big buildings having even bigger carbon footprints. Luckily, a solution is around the corner. Geothermal heat pumps could play a huge role in decarbonizing climate control. Today, we're talking to Joselyn Lai, the co-founder and CEO of Bedrock Energy, a company working with buildings to install geothermal systems. Sadly, Becca isn't with us today, but we're joined by TechCrunch's very own climate reporter, Tim Deschamps. Hey, Tim.
Hey, Dom. How you doing?
I'm good. How are you?
Good, thank you. Happy to be here.
Yes, thanks for hopping on this conversation with me. This is super exciting. But of course, before we dive into the conversation with Joselyn, we play a game called Two Truths and a Lie. So for our listeners, you guys pretty much know how this goes. Listen carefully and see which one of these statements is a lie. And then, of course, after the episode, we'll tell you. But okay, which one of these statements is simply not true? That geothermal heating is proven to be efficient, which helped them a lot in raising their seed round. That the holes they drill are up to 2,000 feet deep. Or that Bedrock is moving into residential projects. And before we jump into the conversation, please remember to rate and review this episode. And without further ado, here's our conversation with Joselyn. Hey, Joselyn, thanks for joining Tim and I today.
It's great to be here. Thanks for having me on.
Yeah, so I guess the best place to start is, can you tell us a little about Bedrock?
Yeah, Bedrock is a technology startup focused on building construction machinery so that geothermal heating and cooling can be a more scalable, affordable, distributed energy type for buildings to go net zero.
And what got you interested in the space?
I met my now co-founder, Silviu Levescu, a little over 2 years ago, and he had been chief scientist of pressure pumping at Baker Hughes. He had hundreds of patents internationally for the oil field. And he was telling me about how a lot of the technologies that he had designed for oil and gas extraction could actually be redesigned for clean geothermal direct use for heating and cooling. And I was just hooked when I heard about this from him, because we know that geothermal heating and cooling has been around for a really long time. So the fact that this technology is about scaling something so cool and so efficient and so beneficial for society, and that there isn't really risk in whether or not it works. It's just about how do we build technology that makes it more accessible in more buildings, more affordable, more available for many, many building owners to do. I really love that, because I think climate and decarbonization is something that really requires very near-term impact and near-term adoption of clean technologies. And that's what got me into this.
So, Joselyn, geothermal's been kind of having a bit of a moment lately, right? There's been a lot of big funding rounds, a lot of companies making a lot of headlines. What do you think is driving that right now?
I think there's a few tailwinds that are converging. One is that the IRA, which was, passed a couple years ago.
The Inflation Reduction Act, right?
Yes, that's right. The Inflation Reduction Act. It brings in incentives that capture and kind of reveal the value of geothermal for society and the economy, right? It is clean and base load, which means that it's kind of always there. It doesn't come intermittently on and off the way other renewables might. And that's really valuable for the grid. It's really valuable for, our energy system. And so the IRA, the Inflation Reduction Act, reflecting that and incentivizing geothermal of all kinds, whether it be geothermal power production or direct use for heating and cooling, as we do at Bedrock, it is an indication of how valuable it is. So that's one tailwind. I think other tailwinds in our space for geothermal heating and cooling for real estate include the fact that real estate is becoming genuinely serious about decarbonizing their assets. And space heating and cooling is the number one energy use and the largest driver of emissions in real estate. And so as you start to see big name real estate firms and developers think seriously about net zero buildings, about more efficient buildings, that tailwind makes it more standard for folks ranging from tenants all the way to builders to look into things that can actually decarbonize the heating and cooling, and geothermal is really the most efficient way to do that.
Yeah, so can we get into the technology a little bit that you're developing? Everybody kind of comes at this with their own approach. What sets Bedrock apart?
There are many great companies that are doing geothermal, as in they construct it, they deliver it, they install it for real estate properties. Bedrock is really the only one building construction technologies for designing and building larger geothermal systems to really, really bring down the costs and bring down the other barriers to adoption, such as space and risk. Our approach is to say, look, the closed loop heat exchange systems in the ground that we have known for many decades work are the way to go. So we're bringing technology that models it better, that models it so that you can maximize the depth you go to and minimize the space you need. And then we go drill it in a way that is faster, more cost effective, and less risky because we have all of this subsurface data coming up from the ground while we drill. And that's absolutely unique in the geothermal heating and cooling space. We're the only folks who can really go map what's going on down hole while we drill and construct these systems and very cost effectively give the building owner the lowest risk, lowest costs, and lowest space footprint system that they can have, and therefore maximize how much of their building's energy load is being delivered by clean heating and cooling from the ground.
So you mentioned that you're a closed loop system. Can you tell us how that differs from the other one, the open loop systems, and why you decided to go that way?
Yeah. So a closed loop system is a geothermal heat exchanger that's in the ground. It's in this borehole. For us, it's maybe, 1,000 feet, maybe deeper. And it is a pipe that goes down and up the same borehole, flowing water through so that heat is being exchanged while the water flows down and flows up. Because it is a single pipe that goes down and up, it's closed loop in the sense that there's nothing being injected or left in the ground and there's nothing being taken out of the ground. So the only thing that is actually being exchanged is just heat. That means that you're not interfering with the groundwater, with the water table. It means that you're not putting anything in the ground that is foreign and you're not destabilizing in any particular way. On the other hand, open loop systems, which have been used for many, many decades as well, do require that same pipe open up to a potentially open body of water, which is super efficient from a thermal standpoint, but it requires that you very conveniently have a pond or a lake or something in your backyard, which I don't know about you two, but I do not have something like that. And that makes the serviceable, addressable market much smaller because you have to not only have that body of water, but you also have to have the permitting and, I suppose, access to it, which is something that, some locations are okay with if it's a municipal system. So I believe the city of Toronto has one. There is a private, I believe, property in San Francisco that is able to access the bay. But increasingly, states will look at that and say, are you going to interfere with a body of water that fish are living in? Will the thermal interaction with that body of water impact wildlife? And so that makes it just a less scalable way to do geothermal heating and cooling, even if it is very efficient.
Can you talk us through the process of getting your first few customers? What was the process like of getting the customers and building trust with them in terms of, using Bedrock in their buildings?
Yeah. There are a lot of people who don't know about geothermal when we first meet them. And so building trust is definitely a really key theme. So our first customers have been folks that do have some kind of requirement to look into more efficient systems. And so our first real estate customer, and we are unveiling a project with them in kind of South Congress, very hip part of Austin, Texas, tomorrow. And this customer is a real estate fund called CIM Group. They have a really, really admirable but ambitious net zero goal. So they have all these millions of square feet of real estate, and they, like many real estate firms now, are looking to decarbonize that portfolio. And decarbonizing the heating and cooling of your portfolio, electrifying your HVAC, is something that often increases your energy bill. And that's a very difficult proposition for a real estate owner because you can't have your tenants pay for your electrification through energy bills that are going up because you chose a all-electric system. And so geothermal heating and cooling is something that electrifies your HVAC, but is so efficient that it actually brings down your energy bills. And that makes it very, very valuable for real estate owners that are looking to achieve net zero or achieve high energy efficiency standards in their assets. So that's one example of why they look to Bedrock. And in that case, a lot of our trust building centers around focusing on the fact that geothermal heating and cooling has been around for a really long time. Geothermal heat pumps are really well established. There's not really risk there, and that helps a lot with trust. There's another profile of customer that has been interested in being an early adopter, and these are folks who have power constraints. They're trying to build new construction. These might be like larger commercial or industrial assets, and there's a lot of commercial industrial being built in high growth areas. Think about logistics and, those kinds of businesses that are growing a lot in a world of e-commerce. And honestly, in places where the utility just says, you can't have as much power as you want. What are you going to do? You just push off the construction of your asset for 2 or 3 years till the utility thinks they can build out more distribution? Instead, why not actually figure out how to reduce your power demand so that you can still have the building that you want, which is revenue generating in these high growth areas? So that's another reason folks have looked at Bedrock and turned to us for a solution for reducing their power demand.
On the note of helping companies or buildings reduce their energy bills, do you work a lot with energy companies? Because I'm thinking here in New York, like, what is the process like of, I don't know, working with something like Con Ed about bills and energy?
Yeah. Well, I will make one clarifying point first, which is that unlike solar or other types of distributed energy resources, geothermal doesn't need to interconnect with the grid. This kind of geothermal heating and cooling doesn't need permission from the utility to plug in and sell kilowatt hours back to the grid. This is a huge benefit because obviously it's difficult when you have to go through that kind of process, and the utility is now thinking, oh my goodness, now I have to figure out a way to accept and pay for these kilowatt hours that these, private owners are putting back onto the grid when they don't need it. The thing about geothermal heating and cooling is that it does sit behind the meter, so to speak, as in it sits on the property, and it just reduces power demand at the most peak stressful times. So it's a benefit for the owner who gets to save money, and it's kind of easier for the utility because they don't have to be concerned about, paying for production that is coming from a private site. In some ways, we don't really have to work with the utility in that sense. You just work with the building owner to give them the HVAC that they need. But there is a lot of interest from utilities, especially in the Northeast, including Con Ed that you mentioned, Dom, because they see geothermal heating and cooling at scale, large district systems that are owned by the utility, as a solution for a couple of things. The first is because of that ability to bring down your power demand at the end user's point, utilities can see geothermal as, wow, this is a way to manage demand. This is what they might call a non-wires alternative to managing demand without putting up with the difficulties of permitting for new distribution, new transmission, new generation. So that's one reason that utilities are actively looking into geothermal and putting in rebates and incentivizing geothermal heating and cooling. The second reason is that some states, like those in the Northeast, really need to solve for clean heat, because heat is one of the largest drivers of carbon emissions in places like New York and Massachusetts. And they really want to get their states off of gas and fuel oil heating. But if they were to purely electrify all of that heat, A, the grid would not be able to support it, and B, the gas utilities wouldn't have a business model. And so by having the utilities potentially own geothermal heating and cooling networks, they can provide clean heat as a kind of new business in the energy transition, where they're still selling heat the same way they did as gas utilities, but this is now super, super clean, renewable heat instead. So those are kind of two reasons that these utilities are really interested in geothermal. And so if we look into the future, 10 years from now, if Con Ed and Eversource and National Grid need to do millions and millions of feet of boreholes in the ground, well, we want to be the company that enables cost-effective construction of all of those millions of feet of boreholes in a clean heat future.
So that seems like quite the evolution for a company like Bedrock, right? You're starting out with private property owners and working with them to put stuff on site, whereas this would be a very different line of business. Is that right? In some ways, same core technology, but working with a new customer, new permitting, new building process. How do you see the company evolving to meet that?
I would just simplify the identity to being folks whose technology can design and construct geothermal fields. We call these geofields, these heat exchanger fields, delivering those at the best cost and the highest accessibility and lowest risk possible. Yes, the customer may evolve over time. We hope the size of these customers evolves over time because the more you can get portfolios of real estate assets and grid systems from utilities as the buyers or the projects that you are delivering geofields to, the more scale we can get for the energy transition. So I actually don't think it would change too much. I think from a sales process, it would definitely change. From a contracting process, I'm sure it would change. But our core technology is absolutely transferable, whether you're delivering 50 bores for a, warehouse or commercial building or multi-residential, or 200 holes for a military base or a campus, or thousands of bores for a utility scale system in a town. It's really the same core design and construction tech stack.
Joselyn, I was wondering, are you, it sounds like you're looking to scale up. Are you also looking to scale down? Like, is this something that I could put in my backyard, say?
We know there's great companies ranging from, small local businesses to Dandelion Energy that are focused on the residential market. Our technology stack is, I would say, meant for maximizing load in a certain amount of space. And as a result, it is meant for larger buildings. I would say something that is 30,000 to 200,000 square foot is just a better use of technology that is really trying to get lots of load from each bore. Whereas one of our bores, it might serve multiple homes because of the load that we're trying to get out of the ground. So it just may not be the best economics to mobilize our equipment for a single family home. That said, in a future where the utilities or towns are actually putting in these systems at scale, then that is how we really want to impact single-family homeowners, which is the majority of homes in the United States. And that's something that we can definitely do with the right partnerships.
I would love to talk to you a little bit about hiring for a company like this. Who were some of your first hires? Like, I guess when you're building a geothermal company, who is the first person you bring on?
Our first hires were engineers, and I think the first two or three were from oil and gas. And it is because the core technologies that we bring to the table here involve essentially subsurface energy modeling that is not that different in some physics concepts from the reservoir modeling that comes from oil and gas. So our first software engineer came from oil and gas. Our first mechanical engineer also came from oil and gas because the tools that we are building are not dissimilar to those from oil and gas. Now, in oil and gas, some of these tools, the bill of materials might be $300,000, $400,000, and the daily utilization might be $50,000. And for us, we have figured out how to get those same capabilities, but into something with a bill of materials that's less than $25,000, and the daily utilization rate would be in the hundreds. And that's really what's required to bring these subsurface intelligence capabilities to the geothermal heating and cooling space. Because that oil and gas, tech is not going to be economical in low temperature geothermal for real estate. So those are kind of our first couple of engineering hires. We then later hired more from oil and gas because we have team members who actually operate our prototype machinery. And you actually do in the prototype stage need folks who are actually very skilled and understand this kind of machinery. And we have really amazing safety habits and practices. And oil and gas is where those kinds of field operational talent come from. With both the engineering talent and the field talent from oil and gas, how we were able to bring them onto Bedrock, the kind of theme of our conversations with them is really that this is a company looking to build clean energy jobs that are very, very suitable for oil and gas workers to bring their existing skill sets. And the oil and gas industry is very feast and famine. In the good years, it's amazing. You get paid a lot. In the bad years, you may have no work for 9 months at a time. And I've definitely heard stories of monoculture oil and gas towns where you'll have PhDs who are working in fast food restaurants, not utilizing their typical skills because it's a downturn and the whole town's economy is really based on oil and gas. So I think there is something around clean energy being a really stable new industry that is attractive to folks who are tired of the ups and downs, tired of having jobs that take them to the Middle East or Nigeria or Southeast Asia in a way that isn't very sustainable for their families and isn't very sustainable just for kind of like lifestyle. And so we're looking to create more jobs like that that are really stable and domestic. And that's part of the pitch to these individuals we hired early on.
Do you guys have a flood of applicants coming in since you have such kind of an attractive lifestyle pitch in that regard?
I think when we have jobs open, we definitely get a good number of applicants. I will say that our first few jobs have been really specialized, right? We are looking for mechanical engineering skills of a very particular type, electrical engineering skills of a very particular type. And so I would love to see a flood of applicants for some of these specialized roles, in part because, what we do, we're a hard tech company. You've got to have really, really great talent to make the whole integrated technology stack come together.
And what is the process of testing out this technology? I imagine it's kind of maybe hard, maybe easy thing to test.
It's, Tom, we've got to actually go out and drill, which is, it's an expensive proposition. Every tool you want to test, every concept you want to test, you're out there in a actual field putting drills into the ground. And so we were really lucky that one of our investors had a site outside of Austin, not too far from our office. And that gave us the opportunity to do our first R&D field trial drilling in our area last year. We drilled several thousand feet, got data, fed that data into our software algorithms, measured our speed advantages compared to conventional technologies. All of that was great from a showcase and demonstration and experience standpoint. But yeah, it's difficult. You've got to find literal land to go do this on.
Where do you usually drill?
So in that case, in that R&D field trial, it was in this, I guess, not yet developed lot outside of Austin. And then actually, after a few months of that, we went straight into our first commercial project. And that was on an occupied office building site. We drilled in their parking lot. So they had to give up their parking lot for a couple of months. We drilled while people were working inside the office Monday through Friday. They were actually very pleased with how much they didn't notice us drilling during work hours. And afterwards, we paved back over their parking lot, redrew the lines, and they have their parking lot back. And this is now a office building in South Congress, Austin, that has geothermal heating and cooling, which is, double or more the efficiency of normal HVAC and is super, super healthy and sustainable right in a building that had been standing there for over 100 years.
Well, you all just dove right in, huh? Trial by fire.
Yeah. I think, there's only so much that you can learn just by drilling R&D holes in a random open plot of land. And to really experience it all, we were like, well, let's just go and do it on an actual building. And yes, it was definitely trial by fire, but we had a really, really great partner in the real estate owner to do this with. And so we're really excited that it is a working HVAC system. It is currently, I think, about 80 some degrees in Austin. So it's providing air conditioning and it's doing so in a super efficient way.
To switch gears just a little bit, I want to talk more about you as a founder. So I guess growing up, did you always want to be an entrepreneur?
I don't know if I knew what an entrepreneur was when I was a kid, but I knew that I wanted to do things that were helpful from a social impact standpoint. I was always just someone who really loved animals and really loved recycling and, told my parents that they had to do XYZ because I learned about it at school and it was better for the environment. So I think that was always a theme. In university, I ended up writing my senior thesis on what is now called regenerative agriculture. But at the time, it was just about kind of like, what are the sustainable agricultural practices that help to keep carbon in the ground? That was one of the earlier moments of me thinking like, this is something that I really care about and would want to continue pursuing. At a certain point in my 20s, I moved into doing startups. And that's when I started to think about, wow, would I ever want to start my own company? And merging that with this theme of sustainability in my life, I ended up a couple of years ago thinking, actually, let me go see if there is a decarbonization oriented sustainability startup that I could be differentially helpful for bringing to the world. And meeting my co-founder, Sylvia, really helped to trigger, yes, this is a company that needs to exist. Yes, I, with my background, could actually help bring this to the world. And that's kind of how it all came together.
Was there a moment where it all kind of clicked for you, or was this a slow evolution where you're like, I have these skills, I have this interest, and I want to merge the two?
I think it was just a slower evolution and a constant theme because a lot of the startups that I've been in the past decade have been sustainability oriented. It was always pretty consistent that I wanted to do startups that had that kind of impact, that had this mission of using technology to make the sustainable or better thing more viable and more commercializable and scalable. So that was always there, but it wasn't until I had several reps of being in startups that I started to think, okay, am I now ready to try my own hand at this? And it's interesting because you want to have enough experience. You've seen, the 0 to 1 enough that you actually know how to get a company off the ground. But you don't want to wait too long because I think there is a moment where you just like have the energy and like have the drive to go try and get something off the ground. So I kind of felt like 2 years ago was the right time for me. And so that was a bit of a aha moment, while kind of the theme of doing sustainability was just a constant.
And you're a first-time founder, right?
I am.
So what have been some of the challenges, some of the ups and the downs of being a first-time founder? Like, was there something where when you were starting the company, something was a lot more challenging than you thought it would be? What has that been like, I guess, emotionally, mentally on this journey?
I think that some parts are familiar, right? Just like building a team in an early stage, you have to, sell the vision and get people excited and look for the absolute best talent. Like those things are constant no matter what kind of startup, and even if you're not a founder. I think the things that have been a little bit just newer to me is most of the startups I've been a part of in the past 10 years were software, right? Because we are in this moment where software is eating the world and software is really the highest return on capital that investors can get. And so the most opportunities for the past, more than a decade for people coming out of university, people moving into startups have been in software. And doing a hard tech company that integrates hardware, heavy machinery, and software, it is just so much more expensive than building software. The different hats you need just in your engineering organization are so much broader, right? We have like 6 different specializations in our engineering team, whereas some of the software companies I'd been a part of fundamentally only had like front end and back end software engineers. And with us, we have, many different disciplines. So that's something that has been, pretty awesome, but sometimes terrifying learning curve for me because you just like spend so much money faster than a software company, but also it really forces discipline in making investments and doing demonstrations that have the highest impact.
You mentioned money or how expensive this is. And so I have to ask, how was fundraising for this company? Climate is like really hot. So I'm assuming investors got it, but you never really know if investors because they're so weird. So like, what was it like? What was it like fundraising?
Yeah, our seed round, which Tim reported on, was a mix of a kind of larger seed round in 2022, and we kind of stayed on the down low a little bit on stealth, and then we added more folks in 2023 and kind of came out and shared about. And that was actually not too difficult because, to your point, there's a lot of interest in climate. I think especially at the earlier stages, there are a lot of seed funds for climate right now. We are lucky to not have encountered what folks are calling the valley of death at the kind of B-ish round when you really need much higher amounts of capital. So I think in the earlier stages, especially our seed, there was a lot of clear understanding of, wow, does geothermal for commercial, industrial, larger properties need to exist? Yes. Our grid needs it. Our real estate industry needs it. That kind of clear consensus that like this needs to exist was something I think, we got a decent amount of agreement on with the investor market. I think that it helps that our technology is not trying to prove fundamental feasibility of something. We're here to really scale. And, a lot of the language that is used by, John Doerr and Bill Gates and whatnot is about like, this is a problem of speed and scale. And so us building something that really has that nearer term impact and ability to deploy, the fact that we don't need 10 years in a lab to prove if something works, that has been a benefit for our conversations with investors. So I think that so far has been helpful. We shall see how kind of like coming rounds will go. One thing that I am really excited about, though, is that because geothermal heat pumps themselves are really well established, we think that not too far into our future, we can actually shift away from equity dollars to balance out venture equity and project deployment capital and equipment financing. And we've actually already brought on equipment financing dollars that made our drilling rigs an investment that was taken off of our balance sheet. And so knowing that that capital is there for when we scale, knowing that there's a lot of dry powder for project deployment, right, for getting debt dollars or project equity dollars into the world for more clean energy installations, the fact that those dollars definitely exist is something that I think will hopefully ease Bedrock's growth in the future.
That's fascinating. It's an interesting way to approach that valley of death that you talk about. It's something that I've been thinking a lot about as I've been covering a range of climate tech startups. And it really seems for your case that the faster you guys can get to that point where you don't need to fund stuff on the balance sheet, that you can work with debt and other forms of capital, the faster it is you're going to get through that and move on to the point where scaling becomes more of an infrastructure question as opposed to kind of a science and technology question.
That's right. And the world is already pretty familiar with infrastructure financing, not least the oil and gas industry is obviously very good at scaling things up through those forms of capital. And of course, in recent years, we've just seen such an explosion in wind and solar. And so a lot of the skill set, a lot of the, I would say, financial products are there. We would have to tweak them to fit distributed geothermal direct use, but we take a lot of notes out of the distributed solar industry. And I think the concept of a power purchase agreement for rooftop solar is something that we look at a lot and is definitely a tool that we can leverage for geothermal. And people are already kind of starting to play with it. And so if we can kind of lean on that when Bedrock is really ready to say, okay, our technology has gotten geothermal to this really, really scalable point, then we can really tap into different forms of capital and different forms of structures to help make geothermal something the real estate owner doesn't have to shell out a bunch of upfront capital for, and we don't have to shell out a bunch of upfront capital for.
What's next for you and the company?
We are really excited that in this first couple of years, just in 20 months since raising our first round of capital, we were able to prove a lot of key demonstrations of our technology on better speeds of drilling, better depths and more space efficiency of drilling, a lot of de-risking because of being able to actually see what's underground when we are drilling and put that into a model that guarantees much better energy performance long term. So there's all these technical proof points we showed in the past 20 months, and we are able to deploy those into a commercial project. So in the next, let's call it next 20 months, next couple of years, we are really looking to bring together all of those technology elements that we have showcased in this past round and go build a integrated, much more robotic and automated construction machine for geothermal heat exchanger construction and technologically get to this cost point on geothermal construction that really says, yep, pretty much any real estate owner can have geothermal in a under 5-year payback period. Even if you do not care about energy efficiency, even if you do not care about the climate, it is a financial benefit for you to choose geothermal. Getting to that point would be this signal that, yes, We are here to scale geothermal to real estate properties that had never been able to consider it before and make it a financial no-brainer for them. So that's our technology and kind of like product goal for this next year or so. And from there, we would want to then go put a bunch of these drill rigs across the country to go help people get to net zero in their real estate properties.
Yeah, and soon the world, maybe?
Yes, yeah. There's a lot of places that really want geothermal. So obviously in Europe, with the conflict with Russia, natural gas prices are really volatile. And so that's a region that is very, very keen on geothermal heating and cooling. They also know about it more than the US because they already have higher adoption rates. And then you see kind of similar things with Asia Pacific, especially some of the island countries that are net energy importers. And so you get a lot of conversation about how are we going to get energy independence and energy security. And these are regions where we would love to go and deploy rigs in the not too distant future.
Yeah, that sounds really exciting. But that is sadly all we have time for today. So thank you for joining us.
Thank you both for the great conversation. Yeah, I appreciate you giving a spotlight to clean energy on the Found podcast.
And that was our conversation with Joselyn. Of course, before we jump into our take on it, what was the lie? Two truths and a lie. Okay, the lie was that Bedrock is moving into residential homes. They are not. Well, not right now.
And there's good reason for that too, right, Dom, as we saw. So I thought that was pretty cool. The fact that the stuff that they're drilling basically is so deep and provides so much heating and cooling power that it doesn't make sense to do on one home alone.
Yeah. I mean, the whole conversation, I was just thinking, I was like, this was an industry and an area I truly have no idea. Like, I know nothing about this. And which is crazy because I took a geology class in college to pass. And then I was thinking back to that moment because I was like, oh, snap. I paid attention, but I should have paid more attention because the themes were there that I was recalling. But I was also like, oh, snap. Because this product, I think, is really, really cool and interesting. Of course, it makes sense to do this, especially for really big buildings. But then seeing the science of actually how to make that happen, drilling, when I hear drilling, I think of oil and, just digging that up. And I was like, oh, wait, we're drilling also for clean energy?
Yeah, exactly. I mean, I think this is one of the interesting cases where development of a technology in another industry, so in this case, fracking, specifically in oil and gas, really drove enough advances in drilling itself, but then also understanding of subsurface geology to kind of make geothermal at this scale and at this depth more possible than it had been in the past, right? Because out in California, they have a bunch of geothermal wells that tap into kind of near surface hot springs and stuff like that. But in terms of drilling deep, that's not something that had been done previously. People experimented with it basically, but the problem was it cost so much money to drill that deep. And now it turns out we've gotten super good at it thanks to fracking, and they can do it quickly and cheaply, and the bores can be really effective. And I think that's really what's kind of paved the way to kind of this resurgence of geothermal that you're seeing today.
Oh, shout out to Big Oil for giving us something good.
Yeah, who knew, right?
I know, right? I was thinking about one thing, and I didn't ask. I guess I was afraid. But if we keep drilling for natural resources like this, could that also cause harm? Could we run out, or I was just thinking there has to be a con of constantly drilling into earth like this.
I mean, there are some limits, right? You can't put boreholes super close to each other or else you're going to limit the efficiency of the overall system. You can think about it, it's basically like a battery. You're dumping heat into it in the summer and then extracting that heat in the winter. And if you put too much of those close together, you're going to just kind of end up with an ice block at the end of the winter. And so you're going to have kind of some efficiency related issues. And they do have some concerns depending on how deep you're drilling. I don't think Bedrock is really concerned about this given their depth, but you do have to watch out for earthquakes and stuff. But they've gotten better over the years at kind of monitoring for seismology impacts and stuff like that.
And I see they've only raised an $8.5 million seed round, which doesn't seem like a lot of money for a company like this. But what do you think the next steps are?
I mean, they're almost certainly going to have to raise again. Whenever you're dealing with hardware like this, it's going to be expensive. There's definitely opportunity around for non-dilutive government grants. But yeah, again, when you're building hardware, you're going to need more money. So the next step is going to be building more and more of these machines, bringing the costs down, and then deploying them to the field and drilling more wells to prove them on a broader commercial basis.
Yeah, this company is so fascinating. It's really interesting to see all of the really, really cool climate focused companies that are coming out, really addressing this incredibly pressing issue. Even like the data collection that they do, I'm thinking of how that could be used in the future to really, really help. I mean, I'm thinking like in New York, all these skyscrapers we have, like could the Empire State Building be run on geothermal heating? All of these things.
Yeah, I mean, it's entirely possible. You could see cases where, like Jocelyn mentioned, they tap into existing grid infrastructure companies like natural gas companies and kind of run what you might think of as a centralized geothermal system, right? Where it is actually distributed, but it's managed by one provider. So similar to the old utility districts that would provide steam heat throughout New York and stuff like that. But instead of steam heat, they'd be providing geothermal heat.
That's so fascinating. I really wish, well, I know that we asked her about this, but in terms of like selling this product to buildings, because it seems like it would be an easy sell, but I know there have to be stories of buildings just not getting it or maybe not wanting to do it at all.
Yeah, I'm sure there are people who are going to be concerned about this. I think the big thing for them is, making sure their footprint is small enough that they can get into the tight spaces. Obviously the challenge is going to be retrofitting. So if you've got a skyscraper in New York, you're very kind of tight tolerances on that lot. You might be drilling in the basement, stuff like that. So it's possible that's where they're going to need to bring in Con Ed, gas companies, stuff like that, where the drilling may happen on the sidewalk, under the street, where these utility companies have these existing right-of-ways, which would, I think, make something like this a little bit easier.
Yeah, because I was like, where would they drill in New York? Like you start drilling and then you hit like the one train or something like where.
Exactly.
Yeah, that would be insane. I also wanted to ask her, because we had somebody on a few weeks ago and they were talking about how they were trying to get trees across the Canadian border. And there were so many like laws and restrictions on just bringing a tree in. And so I wanted to ask if the company expands, like, I don't know if you would know this, but you might. Are there restrictions in terms of drilling in other countries? I imagine like if they wanted to just go to France or in something and start drilling, what would the French say? Aside from like, what? But like, how would that work? Are there any restrictions like that?
That's a good question. Not that I'm aware of, but that doesn't mean they don't exist. In a lot of states around the US, there's really well-developed law around mineral rights and what exists underground. And here you're not drilling to pull something out of the earth. So I'm sure the regulations around that are going to be a little bit different. And that's probably a place where you're going to see evolving laws and regulations over time. But I think a lot of it's going to come down to the company's kind of social license to operate, right? Like if they can come into an area, prove their case, and show that there aren't going to be any adverse effects, that the community is going to benefit in the aggregate, that's probably what's going to allow them to proceed.
Yeah, this seems hard. Looking at all this, the cost, the hardware, drilling, it seems like it's hard.
I mean, these bets wouldn't be bets if they weren't a little bit challenging. But I will say that I think, again, kind of bringing it back to the oil and gas thing, everything that we've learned from drilling from oil and gas is going to make these companies and their developments a lot easier and a lot more possible. So a big part of the technical and science risk is done. And so what they need to do is they need to kind of prove that the subsurface geology, as they call it, basically how the dirt and the rock look underground and how that interacts with the rest of the geothermal system, they need to prove that their system works well in those cases and that the performance of the system is going to hold up over time. And, there's ample data in this space from other geothermal installations that I think is going to contribute. And so the fact that they're collecting all this data on the way down is going to give them a lot of information when it comes to modeling that geology and kind of creating a digital representation of it so that they can forecast the performance. I think really in this case, the biggest risk is, finding customers and then proving that the technology works over time. But I think they're well on their way toward proving that.
What's stopping big oil from just copying this exact business? I should have asked them that.
Yeah, no, I think they totally could. But I think the reality is that big oil hasn't necessarily shown themselves to be that interested in diversifying outside of resource extraction, right?
They really haven't.
Oil and gas. This is what they do. Every time they come in, they kind of lose interest after a little bit. And you might see their corporate venture capital arms come in and invest in companies like this. That's happening. But that's really just to kind of keep their finger on the pulse. And maybe if some of these get really big, you might see an acquisition at that point by an oil and gas company. But I think they're kind of waiting to see how it develops.
Well, I'm rooting for anything that takes down big oil, honestly. That's my stance.
Found is hosted by myself, TechCrunch senior reporter Becca Skutak, alongside senior reporter Dominic Midori-Davis. Found is produced by Maggie Stamets with editing by Kel. Our illustrator is Bryce Durbin. Found's audience development and social media is managed by Morgan Little, Alyssa Stringer, and Natalie Kreisman. TechCrunch's audio products are managed by Henry Pickavid. Thanks for listening, and we'll be back next week.